Hello students, I am Sachin Prakash and I teach and mentor students in chemistry for IIT. I believe that the real confidence which is required to crack this IIT exam will come only when you are confident in tackling good problems. And that clarity and understanding of concepts will only develop when you are really comfortable in handling these problems. So this video contains the paper discussion which I have conducted in my uh, classes online. Okay, and a lot of good doubts are there which I have discussed here. It will be helping you people in understanding, developing an understanding in how to approach and tackle good problems. Okay, and if you like this, if you found this paper discussion video to be useful and interesting, you can like, comment, and subscribe to this channel, which will surely motivate me to add some more useful videos of this type. Okay, because ultimately it's this is just an effort, honest effort, small honest effort from my side to help the student, uh, help my students as well as other students also in their ITJ preparation. So let us begin with this paper discussion. Okay.
Yeah. So, hello people. Today we are going to discuss WTM 10 as well as WTA 10 because it is periodic properties paper. Okay, so we'll be having both the discussions today only. So this is a paper in front of you. You know, these paper looks easy. Okay. So there are like 75 questions are here. Okay. So first, let us go through this paper and then we will be discussing the advanced one. Okay, so 51 to 54. Any doubts?
No, sir. No, sir.
No. Okay, I think all the questions are very factual. 55 to 58.
No, sir. No, sir.
No. Okay. Then 59 to 64.
64.
Huh?
64.
64. The correct order of radius. Okay. Now you see, when you are talking about radius, okay, then generally radius will be decreasing as you go from left to right. Okay, except for the what you say, noble gases, for which we don't consider covalent radius, we consider ionic van der Waals radius. Okay, so you see sodium, beryllium, and boron. Sodium, sorry, not nitrogen, beryllium, and boron. Now, beryllium will be less than boron, that is good, but nitrogen should be greater than boron. Are you getting a point? Yes or no?
Sir.
Sorry, should be reverse, no? It should be like this. Beryllium should be greater than boron.
Greater than nitrogen.
Greater than nitrogen, yeah. Now it is like that.
Or why is the third option wrong?
Why the third option is wrong? One minute. Lithium, sodium, and potassium. Okay, this is. Have you checked the values? Okay, on a sodium size, atomic size of sodium is given to be like. Okay, I have this NCRT open with me. Okay, so there are some things which I saw today. Okay, we will have some discussion on that also. Okay. Yeah, you see lithium, sodium, potassium. The atomic radius is increasing only, right?
Yes, sir.
Yeah, so this trend is also correct.
Yes, sir.
Yeah, so this is correct. 64 is going for correction. Okay.
Yes, sir.
Answer will be 2 as well as 3. Okay. 63rd.
Option 2.
Which option? All options.
Second one, sir.
Carbon greater than nitrogen in terms of electronegativity. That's wrong, no?
Yes, sir.
Yeah. So issue? Any confusion in this?
No, sir. No, sir.
Okay. Any doubt in 63? Any of the options?
No, sir.
No, sir.
No. So 64 is done. If you have anything to say,
Explain
yes, yes,
68,
can you?
sir.
68.
Sir, 67.
Yeah,
67 third option is
68.
I do.
67.
One minute,
67th.
1 minute, 1 minute.
అందులో maybe degree కావాలి.
Yeah, can we do it
ఎన్ని
one
బుక్కులు
at a time?
టికెట్స్
See, 67, they are saying covalent radius of 14 and neon. Okay. Now, you see,
Sir,
if, yeah,
ఒకటి ఎన్ని
for
చెప్తాను.
noble gases, we take van der Waals radius. No?
that is the thing. Covalent
gave me
radius is
any-
not defined for, so this is going for, you know, this is going for actually fourth. It cannot be predicted.
Cannot be
because-
predicted.
Okay. It cannot be predicted. Okay. So after 67, 68,
No, sir.
okay. Up to 70, no doubts? Huh?
70 option D, sir.
68, sir.
A, sir.
68.
Okay, 1 minute. One at a time. Okay. That will be easy. There is a lot of
option 67 option what sir?
1 minute. One at a time. Okay. Just one of you open it and say. One of you.
Sir,
Option
70.
70, which option?
Fourth option.
Fourth option.
Fourth
Okay.
option.
Let us see 70.
Sir,
Okay.
58.
Okay, first let me do 70, then I will go back to any other option which you're asking. Okay, one at a time. Okay. So you see in 70, you are having magnesium. Okay, and aluminum. Now, if I am talking about third IP, this means I am talking about Mg2 plus going to Mg3 plus, right?
Yes, sir.
And in this case, I am talking about Al2 plus going to Al3 plus. This is a stable configuration, so this IE will be very high. And this is going to a stable configuration, so I will be lower. Getting my point? So given that the third IP of magnesium is greater than third IP of aluminum is a correct statement. They are asking for the incorrect one.
Sir, first IP of Mg will be Mg to Mg plus, right?
Yes. If I'm talking about first IP of Mg, then it is Mg going to Mg plus. In this case, an Al going to Al plus. In this case, again, the stable configuration is disturbed. So this ionization potential energy will be higher.
Sir, once can you scroll up?
No, this is only the thing. This is not a part of this. Yeah.
Sir, no, this is an option 3 or 1 sir.
Huh?
Sir, 70.
1 minute. Again, if there is a lot of.
Sir,
Huh.
once can you again explain that last part which you said?
In 70th.
Yes, sir. That's stable.
You see, Mg2 plus is a stable configuration, noble gas
Yes, sir.
configuration. And then it is going to Mg3 plus, the third ionization energy. So when you are disturbing a stable configuration, then the ionization energy requirement will be more. If you are getting a stable configuration by doing ionization, then the ionization energy requirement will be low.
But first IE should be Mg to Mg plus, no? Sir?
Yeah, so Mg is having a stable configuration, no? NS2. Al is having NS2 NP1. So if you are
Sir, why is the fourth option wrong?
fourth option is correct. It is asking for the incorrect statement, not the correct one. Fourth is correct. Second is the wrong statement.
Sir, first is also wrong. Sir, in the exam they asked for the correct statement, sir.
Yes, sir. In exam they asked for correct
Sir, they asked for incorrect.
Yes, sir. We said
Incorrect
only, sir.
Incorrect only, sir.
Incorrect only, sir.
Here, see, the thing
correct
is,
only. Sir.
okay, 1 minute. See, if they ask for correct statement and you have the snapshot, we can forward it to Sirisha ma'am and then some action can be taken on it. If,
Okay.
okay, but from the paper which I am having This is a correct one. Are you getting a point? So the paper discussion is based on the paper which I am having. Are you getting a point? Okay. So if there is any doubt in this, we can discuss. Okay.
Once can you explain 53rd question?
53rd. 5-3. This one. This one. Yes, no. Say something. Yes,
No,
no.
52nd, not 53rd. Sorry.
52nd is simple, no? The screening effect of d electrons. Screening is the shielding effect. We know that the d electrons have poor shielding. It is much less than s electron. S have the highest shielding effect because penetration power is high. They're more closer to the nucleus. Getting my point? Yes or no?
Okay, sir. Thank you.
Okay.
Sir,
So up to 70, is it done? Any other doubts?
Sir,
Yeah.
sir, in 70th first option, in periods ionization increases, no, sir.
You see, they are comparing first ionization energy of magnesium and aluminium. Okay, now I have given you that generally ionization energy will be increasing as you are going from left to right. This I have given or not? Yes or no?
Yes, sir.
But I have also given that the stable configurations are exception to this trend.
Sir, but both are stable, no, sir. Aluminium and magnesium.
How is magnesium aluminium stable? Aluminium is like 3s2 and 3p1 and magnesium is 3s2. So it can easily lose an electron and Al plus will be a stable configuration. So the ionization energy requirement will be less. This, if you are going to 3s1, then you are disturbing a stable configuration. So the ionization energy requirement will be more. Getting my point?
Yes, sir.
Okay.
Sir,
Yeah.
can you say 69th question?
Yeah, I can say. Yeah. Any other doubt in this question? 70.
no, sir.
No.
69. 4 elements in a are therein. So you say you have to check the options one by one. Lithium and beryllium, which will have higher ionization energy.
Beryllium.
Beryllium. So it cannot be this trend because first one is having higher ionization. Then carbon and nitrogen, which will have higher ionization energy. Nitrogen. So it cannot be 800 because it is lesser than this as well as this. Beryllium and boron. Now beryllium is having higher ionization energy than boron. So first two elements are satisfied, and then carbon is having more than boron, that is also correct, and nitrogen is having more than carbon, that is also correct. So third is correct. Fourth one, sodium, magnesium. Okay, same logic. Okay.
Sir,
Yes.
Sir, once explain.
67th one, why can't we think that neon is van der Waals radius? Like we know the question now, sir. Neon is van der Waals radius.
No, see, they have given that covalent radius. No.
If answer is cannot be predicted, then it means that in question there is no sufficient information. But the given information is wrong, no, sir. Why can't we think that a neon is van der Waals radius and put the answer as 3?
Because they have given covalent radius. So either it will be 4 or it will be delete. What do you want me to do? Put delete.
Delete, sir.
Okay.
Sir.
I will recommend it for deletion only. Be happy. Okay. Any other requests? No.
Sir,
Yeah.
once explain 58, sir.
58. Okay. Which option do you want me to explain?
Sir, why not A, sir?
It reflects the sequence of filling of electrons in the different sub-energy level. That is the case, no? You see, first S electron. Suppose you are talking about 7th period. Okay, or 6th period. Then first 6s2 gets filled. Then 5d. Okay. And actually 6s2, then the electron goes to like 4f. Then 5d is completely filled. And then it goes to 6p. So this is the order of filling of orbitals as per the off-Bohr principle, with slight exception.
So what is relative ionicity of bond between any two elements?
Yes, the fourth option, why is it wrong?
Fourth option once can you explain?
Okay, it is asking which of them is not true. So these are true actually.
No, sir. Yes, sir.
They are asking not true. This is not true. You
Yes,
cannot predict the stable valences by just looking at the group number.
Sir, what is fourth option, sir, then?
Relative is ionic nature between the bond. So ionic nature will be high if one is a metal and another is a non-metal. So by just looking at the group numbers, you can tell which one is metal and which is. So if I am having a combination of a group 1 and group 17 element, it has to be a metallic ionic bond, no?
Yes,
so I am
sir.
able to predict that the ionic nature is there. That is the thing.
Sir, but it's not applicable for all the elements, right?
See, you are able to predict the ionic nature relatively. Suppose you are talking about aluminium and chlorine. Okay. Now you see, aluminium and chlorine. Aluminium is what you can say less electropositive than sodium. So the ionic nature between aluminium chlorine will be less compared to ionic nature between sodium chlorine. Getting my point?
Sir, in A they are asking sequence of filling, no, sir.
Yeah, the sequence of filling is there, no? Suppose I am talking about sodium and then magnesium, then aluminium. So you see, first 3s1 is getting filled, then 3s2, then 3s2, 3b1. So it is the same sequence in which you are filling electrons in off-bow principle.
Okay, sir.
Okay, you have to think a bit. Okay.
But we can predict stable valences in groups, no, sir.
How can you predict the stable valences in group? Tell me. Suppose I am saying group 17. Okay, group 17 will have a lot of, group 17 you are having like 2 stable valences. Group 13, 14 and 15. But then which one is stable depends on the inert pair effect, not on the group number.
Sir?
Yes.
Sir, 58 question, fourth option is valid for like certain elements, no, sir.
No, almost for everyone. See, from group number you can predict the thing is from group number you can predict the electronegativities. And from electronegativities you can predict the ionic nature of the bond. If there is a huge difference of electronegativity between two elements.
So this is applicable for only elements which form ionic bond, right? What about the rest?
See, if ionic nature is less, this covalent nature is more. Are you getting your point? There can be two things only, sharing or donation. So if sharing is less, donation is more. Donation is less, sharing is more. Getting your point? Yes, no?
Yes, sir.
Yes, sir.
Yeah. So, shall I move forward?
Yes, sir.
Okay. 71 to 75.
71 range.
Yeah, there will be no range in this because the answer is like 1.8888.
Yes, sir.
Okay,
Yes,
so
sir.
here I can't recommend any range because if you round off, it will be exactly 1.88.
0.88. But 1.8, sir.
1.88.
How can you say 1.88 when they have said that it has to be rounded off to second decimal place?
They did not give instructions.
They did not give instructions. But we didn't get any.
That is not mentioned in the question
One
paper,
minute.
sir.
See, the thing is that this is your how much 10th WTM. I think by now you should be familiar with the instructions. Whether they give it or not.
Sir, in the advanced.
One decimal place also. You don't know.
The idea is that I don't think that they will.
Sir, in 72nd question, they not given total question, sir.
Yeah, so this is going for deletion.
So 71, 1.88.
So we get
I don't think that they will consider the range.
Yes, sir, 1.88. 1.8.
If you know that it is 1.888, no. So why will they consider 1.88? They will consider 1.89, no. When they have given that you have to round off to the second.
Sir, but we don't know that we need to round off to second.
This is your 10th exam.
They may ask to round off by one decimal place also, no, sir. How can we think about it?
See, the thing is that you know the instructions, no? They are assuming that you are knowing, you have been giving. See, if it was your first test, then I would have suggested the range.
So even in single test, they haven't mentioned these instructions, sir.
Yeah,
Yes,
this is a technical problem. This you can forward to Sirisha ma'am. But they are not giving the instructions for different sections in the exams, online exams. This is a technical thing which can be forwarded.
Sir,
Yes.
can you explain 73rd question?
Yeah, I will obviously explain. Can I move to 7? Yeah.
Sir, it is not even considering more than 1 decimal, sir.
No, it will be considered, no? Why won't it consider?
It is considering.
Yes, sir, it's considering.
Then, see, whenever you have an error, no, take a snapshot of it. Okay, then you will have a case which we can, forward to the technical authority. Okay. So, question number 72. See, in 72, the actual question was, based on whatever the solution they have given, which of the following elements belong to the same group? Now, you see, 3 and 11. So, if we are talking about lithium is third. 3 and 37 will belong to the same group. 8 and 16 will belong to the same group. Others won't be, belonging to the same group. So, if 72 was a full question, this would have been the answer. Okay. Then it would have been a good question, but they have spoiled it. Okay, 73. In 73, this is a problem.
In 72nd question, there are 2 different groups, right?
Two which belong to the same groups.
So the answer is 2 different groups, right? Like 3 and 37.
No, 3 and 11 belong to the same group. And 16 belong to the same group. So answer will be 4 now. 3, 37, 8 and 16. Getting a point. If 3 belongs to 37, then 37 also belongs to 3 now.
So why can't we think in a way like all these elements they belong to a single group, and why can't we write the answer as 2?
How many answers are given? See, there are like 9 different options. Okay. So if you consider the superset of this, then the answer will be 5. Means the anti-set, means which do not belong to the same group. Are you getting a point? Not 5, it will be more than 5. Then it will be.
Sir, how can we consider elements belonging to 2 different groups as like same set, same group?
No, see, the question will be which belong to the same group. Means based on the answer they have given, they were meaning this question only. Okay. If it is different groups, then
sir, but how do they expect us to pair 2 and write it as a single group?
No, you see, it's like you have to think of it. Like I have told you that lithium, sodium, potassium, rubidium, cesium, they all are belonging to the same. I have given you this thing, no? Now, if lithium is 3, sodium will be 11, potassium is 19. After 19, you get a d electron. So next will be 37, then 55, and then 87.
Sir, what am I saying is like we got 2 pairs like from first group and 1 from 16th group, right? How can we consider these both as a same group and write the answer as 4?
No, you see, group 15 you are not getting anyone, no?
Group 16, sir.
Yeah, 8 and 16. So this will be like these 2 elements belong to the same group. And these 2 elements, they are not asking pairs, they are asking number of elements. If they are asking pairs, then the answer will be 2. They are asking how many elements, so it will be 4. It is an interpretation based thing. Are you getting a point?
Sir, 74, it should be 2 by 2.8, no, sir.
Can you first do 73?
The 73rd one minus 13.62.
Minus
1
13.62.
minute. First understand what is the question saying.
Delta H will be minus.
We should always write it in terms of delta so that there is no confusion. Okay, see, x plus electron giving x minus. So that delta H is minus 13.62. Okay. See, first we have to start with the second statement. That the ionization potential for x minus is 13.62. Means x minus, what is giving x plus electron, delta H is 13.62. If I reverse this equation, I will get this. For this, delta H is minus 13.62. This is the electron affinity equation. So whatever energy is released is electron affinity. So this delta H is basically electron gain enthalpy. So minus 13.62 is minus EA. So EA is 13.62. Are you getting my point?
Yes, sir.
Okay. So 74. The 74th I have given you the, I think,
formula.
Yeah.
Only can scale we can calculate and by 2.8 we can do.
Yeah. I was not expecting that they will give this question, but luckily for you people, you are knowing the formula. So it is good. But don't expect this type of questions coming in IIT-JEE. Okay.
Sir, why did we divide by 2.2?
And see, these two are empirical scales. It is like I decided that I will give some value to fluorine. And then, I will decide some method to, what do you say? Like if I say, which of them are you people are the best people. You see, there is no such criteria, numerical criteria to decide a bestness. Are you getting my point? Okay, so you see, I can decide based on your marks in chemistry. I can also decide based on your marks in physics. Now, it may be the case that some of you like chemistry much more than physics. Okay, generally that is not the case, but generally. And some people can be liking maths much more than physics and chemistry. So you see, there is no universal criteria to decide. So I will propose my own empirical formula that so since Pauling and Mulligan both were the great, very great chemists of their time, they decided their own methods of allotting numerical values of electronegativities to the elements. Okay, so that we can, start comparing them. Are you getting a point?
Yes, sir.
Yeah, so that is the thing. So these scales are empirical scales. That's why IIT will never ask these formulas in the exam. They are not interested in empirical things. Okay, after this, 75 is a doubt? Yes.
Yes, sir.
Yes, sir.
Yeah, in 75, it is asking azimuthal quantum numbers are now given as L 1, 2, 3, 4 instead of L is equal to 0, 1, 2, 3. Okay, so this means that P block will be L is equal to 2. Yes or no?
Yes, sir.
So how many orbitals will be there in P block? P subshell 2L plus 1? It will be 5. Okay, so if you have 5 orbitals, but it is given that spin quantum number can have only one value, means you can only have one electron in an orbital. So total number of orbitals will be 5. The total number of electrons in those orbitals will be also 5. So when you're filling it as per the Aufbau principle, only 5 groups will come in the P block. Are you getting my point? Right now you get 6 blocks because 3 into 2, 6 electrons are there. Are you getting my point?
Yes, sir.
Yeah. So I guess that with this, I can say safely that, yeah.
In 70th question, sir, I got the question as which of the following is correct, sir. But I don't know that it's going to be incorrect, so I didn't take any snapshot like that. Like how? What should I?
Okay.
Yes, sir. Like even we face such issues, sir.
See, what I'm saying is that it is okay. Did you understand the logic or not? Tell me this.
Yes, sir.
Yes, sir, understood.
Okay. Then that is the only thing which you are going to take forward in this preparation. The marks are not going to get forward from here. Whatever marks do you remember how many marks did you get 5 tests in WTM 5? Do you remember it right now? No? But the things which we discussed in WTM 5, they might be, be helpful in the UTM, which is going to come. The marks are not going to matter. What points which you are getting is going to matter. Okay. Yeah, I know that it feels very disappointing when you lose marks because of these silly reasons. But then the idea is this is not the final exam. Are you getting my point?
Yes, sir.
Okay, so just make a note of the points which you thought of. Like, say, a lot of times it happens with me also. Okay, when I was a student, I generally used to get confused between, not confused, means in the rush of time, rush of movement. Sometimes we, see correct instead of incorrect or something like that. Or sometimes it might be that the paper is Now it's online, so we can't predict that also. Okay, it might be the case that you might be seeing incorrect, but then the idea is that we have to ignore those things. Okay, we can't take too much stress regarding that. Okay, there are a lot of
Yes,
things to
sir.
take care. Okay, can we move forward? With
70.
this, yeah.
71, if we write 1.8, we will not get marks, sir.
I don't think that they will consider, but I will suggest a range. Okay.
Sir, 1.88.
Yeah, I will suggest a range from 1.88 to 1.89. Okay. Now you are happy? I will suggest from my side. Let us see.
1.8, sir.
Huh?
1.8.
No, 1.8 they won't consider. I'm telling you. Because 2 decimal places they are giving. You cannot say 1.8.
But
1.88.
Exam, sir.
Yeah?
They didn't give an exam, sir.
Yeah, but I don't think that 1.8 they will consider.
Sir, I gave 1.89 only. It will be considered, huh?
Yeah, that is the answer, no? 1.89. That is the official answer is 1.89. Don't worry. Okay, see, don't be worried about mathematics part. If you understood the chemistry part, I am happy. So let us move forward. I think this paper is done. Okay, so let us open the advanced paper. This is the advanced paper. Okay, and 1 minute. This is the advanced paper. So today I have to discuss like 3 paper discussions back to back. Okay, so let me just, So in advanced paper discussion, we will be covering some good points. Okay, so let us start the advanced paper discussion 1920. Any doubts?
19, sir.
Yeah, 19, which option do you want me to discuss? All. Which option in 19th? See, only B is the only incorrect statement. Okay, noble gases will have high positive electron gain enthalpies. That is correct. See, noble gases don't want electrons. If you're trying to force an electron on them, you have to give energy to do that. So they will have large positive gain enthalpies. Okay. Then
so the 20th one.
Yeah, first, let me first do 19 first. Option C, someone is saying variation in electron gain enthalpy is less systematic than variation in ionization enthalpy. See, ionization energies generally are decreasing down the group uniformly, but electron affinities are not decreasing uniformly down the group. Okay, that is the only reason of this statement will be considered to be correct. Okay, because generally we have a similarity of properties down the group. Okay, so that trend we get for ionization energy, but we don't get for electron gain enthalpies. Okay, you see, fluorine is having lesser electron affinity than chlorine. All the group 2 elements will be having lesser electron affinity than group 3 elements. That's right. Okay, so 19 is done. After that, 20th. 20th, which option?
Not
A and B.
A and B. Sulfur, see, we always know that electron affinity values will be, oxygen will have the least electron affinity value. I think I have clarified this on the doubt group also. Yeah, so it is like that. See, the values you can't mug up. Okay, if you wish, I can show you the values. Okay, electron affinity. Okay, Google search. Okay. I think I have shared this data there also. So 1 minute. Okay, yeah, this was the data which we are talking about. You see, when you're talking about oxygen is having the least electron affinity in the whole group. But then again, it is a database thing. Okay, so they are asking it like that only. Okay. So generally, that is the case. We know that our second period elements will have lower electron affinities, but oxygen in this case is having the lowest electron affinity in the whole group. Okay. So this is something value-based, data-based. Okay. So, you know, this cannot be really predicted by logic. Logic, you can only give that why it is less. Okay. So after this, 20th A, B is that. 20th is done, yes or no? Okay, 21st, 22nd. Yeah, in 21st, I want you people to make a correction. Okay, because this was given in the older NCRTs. Okay, and all the older books are having that data only. Now they have changed it. Okay, so just 1 minute. Let me just. This is the WTA paper, no? Yeah, now this is the WTA paper. Okay, now you see in this paper, I have given oxygen greater than fluorine greater than nitrogen. That is not the correct one. Okay, they have rectified it in NCRT. See, earlier NCRT has not rectified it, so we have to, even though I was knowing that this trend is incorrect, you know, we have to follow NCRT for the means pattern. Okay, but now NCRT has actually rectified it in the newest editions. So the order is nitrogen greater than oxygen greater than fluorine. These are the values, 74, 66, and 64. Are you getting my point? Yes or no?
Yes, sir.
Okay, just make that correction in the notes also. Okay. Till 2017 or 18, they have not made that correction. I think only last year they got their things right. Okay, so just do this thing. Okay. After that, 20th is clear. I think other options are good. 21st. Cation will have, if positive charge increases, the radius will decrease. If negative charge increases, the radius will increase. Okay, so that is why A and C are correct. Titanium, as you go from left to right, the radius are supposed to decrease. Okay, so titanium will be less than vanadium, not greater than.
So can you also explain D option?
Option D, see, this is titanium and vanadium. Okay, so titanium should be greater than vanadium, not less than vanadium.
Okay, sir.
Okay. So after this.
So 22nd.
Yeah, 22nd.
Last option.
Last option. First ionization potential of nitrogen is higher than first ionization potential of fluorine. That is incorrect. I have told you that due to the stable configuration, the trend is temporarily disrupted. So you see, we have carbon, nitrogen, oxygen. Fluorine is still greater than nitrogen only. So it is that fluorine greater than nitrogen greater than oxygen greater than carbon. Trend is like this. Getting the point? Yes or no?
Yes, sir.
Halogens are supposed to be having the highest electron, you know, like ionization energies in their respective groups if you are not considering noble gases. Okay. 23rd, you want me to discuss 23rd, I guess. A lot of people are asking this thing.
Yes, sir.
Now, you see, in these type of questions, there are two things which you should keep in mind. First, that for stable configurations, okay, electron gain enthalpy will be positive, means if you are forcing an electron, then you have to give energy. This is the first thing. Second thing is, ionization energies will always be positive, endothermic, because removing an electron requires you to give energy to break that attraction between nucleus and the electron. Third thing, for, you know, like ions, for anions. Okay, for anions, if you are talking about electron gain enthalpy, anions will not take electrons because inter-electronic repulsions will increase in that case. I have told you that except first electron affinity, all other electron affinities will have negative values. Means that electron gain enthalpy will be positive. You have to give energy to form a higher negative charge ion. In this case, it will be positive only, it will be endothermic only for anions. So if O minus is going to O2 minus, then it will be positive only. Okay. And last case is when you're talking about cations. Okay. So suppose I'm talking S minus plus electron. Okay. Now you just analyze it as per what I have discussed right now. Okay. So can you tell me what will happen in this case? Delta H will be positive or negative?
Positive.
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 Okay. Second case, neon plus electron. Delta H.
Positive.
Positive. Okay. Based on what I have discussed right now, I want to take the decision. Nitrogen plus electron giving N minus. Positive. Okay.
Positive.
And okay, now you see the last question. Last question, they have written it in minus format. Okay, it is a bit confusing. Always convert it into the plus format. The plus format will be Al plus electron giving Al. Okay, now you see we don't know this expression. So what we know is Al, if I give Al plus electron, for this the delta H is equal to positive. Yes or no?
Yes,
for
sir.
this, the equation will be reversed.
Negative.
So it will be negative. So this will be endothermic reaction, exothermic reaction.
So once again, could you say for Al?
See, the reaction will be something like this. Yes or no?
Yes, sir.
Now we don't know this format. We know ionization of aluminium. So aluminium, when it ionizes, it gives this equation. For this is endothermic. So the reverse reaction has to be exothermic, which is this. Getting my point? Yes or no?
Yes, sir.
Okay. And you can always understand it like that if plus and minus are coming together, energy will be released. If minus and minus are coming together, you have to give energy. Are you getting my point? If you are taking out minus from plus, you have to give energy. Are you getting my point? Yes or no?
Yes, sir.
So this type of understanding will help you. Okay. So because you can, feel these things. That you are already having positive charge and you're asking a negative charge out of it. It's like you are already poor and someone is asking money from you. You won't give. Okay. So I have to, spend some energy, I have to convince you like for 1 hour in order to get money out of it. Okay, so it is like that. Are you getting my point 23? Because there is one more question of this type which we have to discuss. 23 is clear, yes or no?
Yes, sir.
So moving forward, 24. 24 you have to check. Okay, 1 minute, just 1 minute.
But 24, can you explain below?
I will explain all the options, don't worry. 24, just let me see. Okay, 24, all options I am going to discuss. First is option number A, 2. 2 is with oxygen, sulfur, fluorine, and chlorine. 2 with 3, ionization enthalpy. So, you see, oxygen, sulfur, you won't get a trend. But with 1, you will get a trend. 2, 1, and R. You see. Electron gain enthalpy, if you are talking about, then basically it is electron affinity order which we are talking about. Then sulfur will have more electron affinity than oxygen, and chlorine will have more electron affinity than fluorine. Are you getting my point? Yes or no?
Yes, sir.
Yes, sir.
Okay. So, and the logic is also given correct that the second period elements are smaller size than third period elements. So they will produce larger electron repulsion, and hence the electron affinity values will be decreasing. Getting your point? So the correct combination would have been 2, 1, and R. But they have given 2, 3, and R, so none of the options will be correct in this case. Are you getting your point?
Yes, sir.
Okay, then 1, 4. Now you see 1 is B plus greater than B. Now this can be judge for the fourth option, electronegativity. B plus will have more electronegativity than B. But for that, correspondingly, there will be no option in option 3. The 1, 3, if I am talking ionization energy, B plus will definitely have more ionization energy than B. But after that, there is no corresponding. Okay, 1, 3, it should be Q actually. Are you getting a point? 1, 3, and Q. Successive ionization energies will be getting larger. Getting a point? But they have given 1, 3, P. P is not a correct explanation. Are you getting a point? Yes or no?
Yes, sir.
Okay. Stable configurations will decide a jump in ionization energy, not the ionization energy itself. Successive ionization energies will always increase, but the jump in ionization energy will be more if you are disturbing a stable configuration. And jump in ionization energy will be less if you are getting a stable configuration. Are you getting my point? Yes or no?
Yes, sir.
Okay. And third, 3, 3. So 3 is basically electron gain enthalpy. O to O minus is negative, but O minus, O to O minus will be positive. The 3 will be corresponding to electron gain enthalpy. So 3 should be 1 and the logic should be S. Electron repulsion outweighs the stability gained by achieving the noble gas configuration. So you see overall also the delta H will be negative, positive only. Okay. Because the repulsions have increased too much, which is offsetting the stability which we are gaining from by the noble gas configuration. So for 3, Q is 3, it should be 3, 1 and S. Okay, so C is also wrong. Are you getting a point? Which brings us to the option 4, magnesium greater than aluminium. Now in this case, they are talking about ionization energy, which is 4, 3 and P, which is correct one. Because magnesium is having NS2 configuration. And this is 3S2, 3P1. Are you getting a point?
Yes, sir.
Okay, so answer is D. 24 is done, I presume. Okay, so let us move forward. 25 to 27.
No, sir.
No doubts.
No doubts.
That's very good.
27.
Yeah,
Sir,
27.
27.
Yeah, that was what I was thinking. Okay. And you see the reaction is chlorine plus electron giving Cl minus. So this delta H is minus 3.7 electron volts per atom. Now this thing I have given in Bohr's theory also. Okay. That 1 electron volt per atom is equivalent to 96.5 kilojoule per mole. You can also derive it, but I have given it as a result. Do you remember? Yes or no? Some people who attended my first
If we
phase
get
classes.
answer is 5.03, no sir.
Sir, we get
5.02.
0.1, sir.
Sir, 1 electron volt per atom can be taken as 96.48455. So many range should be
Yes.
considered as.
Yes, sir.
Okay.
Yes.
What are you getting as answers?
5.01.
5.02.
5.03, sir.
Okay, so then I would recommend.
5.02.
Okay, in this case we have to suggest a range actually. So I can suggest 5 to 5.1. Okay. You people will be happy with this. Yes?
Yes, sir.
Okay. But don't go very extremes in considering this. Use this formula. That is better. Okay.
Yes.
You won't be having calculators on the final J exam. Okay. So you're quoting 96.4855. That will be difficult to do the calculations in the final exam manually. Okay. After this, 28, 29, 30, 31.
Sir,
28,
28.
29, 30. 28.
4, no, sir. 28.
Okay, I have written the configuration so that will be easier. You see, if I write the third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Argon is also considered, no? So you see, sodium is having less than the adjacent element, aluminium is having less, silicon is having less, sulfur is having less, chlorine is having less. Okay, so 1, 2, 3, 4, 5. Getting it? You have to consider the noble gases also.
I did not consider that.
It's okay. It's okay. It's okay. Okay. These things are not very big conceptual mistakes. Okay. 29. Now 29, someone was posting a problem similar to that. So do you have any doubt in this?
No, sir. What is?
Okay. So basically, if you are giving 600 kilojoule mole, all of M will be converted into M plus. Then you are M plus to M2 plus, only fraction will go because you have only 400 kilojoules of energy left. I think you can do this question. 30th question.
Sir, once can you explain 30th question?
In 30th, you see, you should be knowing the CO, NO, and N2O. Okay, these are neutral oxides. Cl2O7 will be acidic, okay, and Al2O3 and AS2O3 will be amphoteric. This is something which is basically fact-based. Okay, so this you have to, you'll be going through a list of all these things when in coming chapter. See, you have S block, P block, D block, F block to go through. So we'll be going through these things. Yeah.
Sir, why shouldn't we consider neutral them as amphoteric?
No. Neutral means it won't react with everything. Amphoteric it reacts with both. Give some credit to amphoteric also. It is doing so much of hard work.
Okay, sir.
Okay. Yeah. So 31.
So 31.
31.
Only 3.
Yes, sir.
In advanced assignment you given, sir.
Yeah, 31. Okay, they are asking which of them is correct one. Okay. The answer is given 3 or 5?
3 you have given, sir.
3.
Is 5.
Huh?
Sir, it's given 5, sir.
They gave 5, sir.
Then I think they are asking for the incorrect statements. No? I think A is incorrect. Ionization potential of boron is higher than beryllium is incorrect. Let me first just check the yeah. So how can we identify them? What? The neutral oxides. This you have to know actually. Okay, so as you go through chemistry, you will be knowing these facts.
Sir?
Okay. Yeah.
I is wrong, sir.
Let me go through it one by one. Okay. First is A. First ionization energy of boron is higher than that of beryllium. That is incorrect. Second ionization energy of magnesium is less than first ionization energy of magnesium. Incorrect. C. Energy is required to convert He to He minus. That is correct. You have to give energy because He is a noble gas configuration. O2 minus is exothermic is incorrect. Okay, you have to actually give energy to make O2 minus ion. Okay. E. This configuration. Okay, now Fe2 plus will have 4s1 3d5. It will have a configuration similar to chromium actually. 4s1 3d5 actually. Okay, so that is correct. This is incorrect actually. E. Then electron affinity of oxygen is lower than selenium. This is the correct statement. So SO3 is less acidic than SO2 is wrong because it is +6 and +4. Okay. CO and NO are neutral oxides. That is correct. And all metallic oxides are basic in nature. That is incorrect. It is some metallic oxides are amphoteric also. So answer should be 3.
Yes, option B once can you explain?
Option B.
G
for Goa, right?
Yes, sir.
Okay. Yeah. You see, I told you that when we are discussing acidity of oxides, that acidity of oxides is directly proportional to stability of oxyanions. It's directly proportional to the positive oxidation state of the central atom. So if you have sulfate ion, Okay, then it will be like +6. If we have sulfite ion, it will be +4. Which one will stabilize anion more? Which case?
SO4 2 minus.
Yes, that is the answer. Is it clear?
Sir,
Yes.
once in classwork when you're saying about acidic nature of oxides, you said that metallic oxide will be basic.
Means highly electropositive metals will be basic. Okay, but you see when you're talking about the aluminum is also a metal, no? See, amphoteric oxides are showing dual behavior. So basic as well as acidic. But when you give that all metallic oxides are basic, then it becomes wrong, no? Because some can react with acids as well as bases. Are you getting a point?
Yes, sir.
Okay, so if I'm saying that my oxide is basic, means it won't react with a base. But AlOH, the whole thrice will react with a base. Okay, so that is
yes, sir.
Okay. Don't worry, these things are something which are understanding basic. Make a note of it in your notes. Okay, so that it won't go wrong in future. 32. Can now, based on whatever I have discussed, can we do it now?
Yes, sir.
Okay, so first, N plus E giving N minus. It is a stable configuration. I have to give energy. So that will be positive. Okay.
Yes.
Delta H will be positive. Oxygen plus electron giving O minus.
Negative.
It will be negative. Okay, this is not a stable configuration. O giving O plus plus electron. I see. O plus plus this will be what? Ionization energy?
Yes, sir.
So it has to be positive.
Positive.
Yeah. Okay. So it is like now H minus giving H plus electron.
Negative.
It will be see H plus electron giving H minus. Is it positive or negative?
Negative.
It is negative. Yeah.
So why it's negative?
See, it's not a stable configuration. No. I have given you the exceptional configurations in the notes.
Okay, sir.
Okay. So for the reverse reaction, it has to be positive only. Okay. Mg plus giving Mg2 plus plus electron. Obviously, it will be
positive.
Positive.
Negative.
Positive, no. Arey, you are asking money from a poor person. Will it give? Yes or no?
No.
So, you have to put energy to the system. Are you getting a point? Yes. Okay. B plus electron giving B minus.
Positive.
Positive, because stable configuration. Mg minus giving Mg plus electron. Now, imagine the reverse reaction. Mg plus electrons giving Mg minus. For this, delta H will be what?
Ionization energy.
Negative.
Positive.
Positive.
Yes.
Because it is a stable configuration, you are disturbing it. So for the reverse reaction, it will be negative only, no?
Yes, sir.
Oxygen plus plus electron. Now you are giving money to a poor person. Okay. So you don't have to make any effort. In this case, energy will be, happiness will be released only. Are you getting a point? Yes or no?
Yes, sir.
Okay. O minus plus electron giving O2 minus. Again, yeah, this will be positive. And P plus electron giving P minus.
So it will be positive.
Now P plus electron giving P minus, it will be actually negative. Okay. Because if you look at the values again, this is value based. Okay. So they have given the answer based on that. But you see, for phosphorus, the electron affinity is is positive in this case. This means energy is released in this case. Are you getting a point? Only for nitrogen it is negative. Yeah?
It is stable, sir. To give electron, we should supply
See,
energy.
the thing is that I have told you people that wherever there are exceptions are not very uniform. That is why it is given that the electron affinity trends are not systematic in the periodic table. Getting my point? These are the variations which they were talking about. Are you getting a point?
Yes, sir.
Okay. So actually the answer will be 4. Okay. So this is going for key change. Anyone who has given 3 as an answer?
Yes, sir.
Okay. Okay. So after this 33, 34, no doubts?
No, sir. No, sir.
35, 36, no doubts?
No, sir.
Now there should not be doubt. I think we discussed almost identical question.
Yes.
Yes, sir.
What did we take? Zinc, right?
Yes, sir.
Later school discussion. Okay. Okay. Yeah. So anyway, yeah, gallium also we took, but I think I took for iron or zinc, something like that. I took it for iron. But anyways, you see, we have discussed all the 2 papers in a single session, which I feel very nice about myself as well as you people. Now you see, since our paper discussion is now done, we can focus on the syllabus from tomorrow. Now, I am stopping the paper discussion now, the recording now. Okay.